So now that we have case 1 down, shading to the left, let's look at what happens when we shade to the right. So instead of saying less than or a less than symbol, we're going to be using greater than because we want the right side shaded of the z-score. So when we have something like this, it denotes probably that the z-score is greater than a. So our picture, very similar. We know zero's in the middle. And again, a could be anywhere. So if I want to put it on the right-hand side, that's fine. But the important part is that I want greater than that, so I need to shade above. All right, so that's the picture. And again, z equal to a could be anywhere on that number line. But how do we find that area? It turns out we're going to use areas to the left to help us get areas to right. So hopefully this 1 minus is ringing a little bit of a bell for you because it's the complement rule again. So remember, if you have the probability all on one side and you want all of the other side, you're going to have to realize that it's all added up to 1. And so we can subtract from 1 to get that remaining piece. So let's see that broken down a little bit. So if we had a probability that z is greater than negative 1.00, the first thing we'd have to do is go to our table and see what's to the left of negative 1.00. So that's what you would do first. This little portion is roughly 15.87% of the whole bell. So we need to know what the remainder from 1 is. So if we said 1 minus 0.1587, we're going to get our answer. So 0.8413. So that should be our answer. 1 minus 0.1587, which is 0.8413. So it's just a twofold step. It's an extra step in the process. You still go to your table, you still look up that z-score, but because it's shaded to the right, you got to subtract it from 1. That's the only extra part to that. So let's try it. So we have our z-score is greater than 2.13. So now if we just draw a little sketch, we know zero's in the middle. Positive 2.13 better be over here on the right hand side someplace. And because it's greater than, we know we got a shade on the right. So just based off of your diagram, you know your answer is not going to be very big. It's definitely smaller than 50%, 0.5. So that just kind of gives you a ballpark in your mind of what you should be looking for an answer. So now, because our z-score is positive, we make sure we use our positive z-score table. And so now we need 2.1, and then we need the 3. So the 3 is right there. So we can cross-reference those. So that looks like what? 9834. So 0.9834. But remember, we should have a little tiny answer. So, I mean, this is always a good thing to have as a relationship, but make sure you write your final answer correctly. So your final answer should be 1 minus that. So 0.0166. And that's it. That's the problem. Now we're going to be doing a lot more of these in a little bit, but this is just to kind of give you an introduction to the different types of probability problems you can see. So we got shaded to the left, we got shaded to the right, and then the last case is going to be shaded in between. So shaded in between. So now they're going to give you 2 z-scores, and you have to look at that area between them. So let's take a look. So we want something that looks like this. So 0. Now they try to tell you that A should be smaller than B. So Now, it doesn't matter how close they are. So, I mean, if you wanted A to be really close to be on the other side of 0, you could do that and have B be right here. So they're looking at this area in between them. So how do we find that area? Well, this one's a little bit more involved because there's two z-scores, but you still need to go to your table for both of them. So that's the key. You want to look at the one that's further to the right, so in this case B, and start with that. Find the probability from your table that corresponds to that one further to the right, then subtract the probability that's on the left. So we will start with the right one, look it up, go to the left one, look that one up, and subtract the probabilities. Do not subtract the z-scores. So do not subtract z-scores. All right, that's a very common mistake. You can only subtract probabilities. You can't subtract z-scores. That won't work. So let's do a breakdown and then we'll try a problem. So here's a breakdown. We want the probability of z being between negative 2.50 and negative 1.00. So the first thing we want to do is make sure we have a picture. Now this is broken up a little bit, but here's our overall picture right here. We know negative 1 is a little bit bigger than negative 2.50, so we should start with the one further to the right. So that's why we have it here. So negative 1.00 gives us this area of 1.1587, which we saw from a previous problem. So now let's go to the table and look up negative 2.50. So let's grab the right table, make sure we grab the negatives. So negative 2.5 and then 0 is going to be right in the first column. So 0062. All right, so we have our first one, which is further to the right. We have our second one, which is further to the left. And so the last thing we need to do is subtract those two. So 0.1587 minus 0.0062. So this should equal 0.1525. And that wraps up that problem. So it's a little bit more involved because you're going to find two probabilities, but essentially you're finding the two, the larger one minus the smaller one. You should always have the larger one first and the smaller probability second. And that's your check. If you get a negative answer, obviously that can't be right because we know probabilities can't be negative. So, all right, let's do it one more time, the new problem. So we got z is between negative 1.57 and 3.09. So let's get our sketch. So negative 1.57, we know it's going to have to be on the left side somewhere. And 3.09 is on the right. So we are going to have a lot of area between these two z-scores. So let's break it down. So let's start with the positive one. So positive 3.09. So let's get our table. So 3.0 and 9 is way over at the end, the very last column. So we got to cross-reference those, make sure you can see them. So it looks like 9990. All right. So 0.9990. And when z is negative 1.57, we'll get a probability of, let's see here, negative 1.5. And we want to go over to 7. So right here. So 0.582. oops, 0.582. So those are our individual probabilities, but our overall answer is going to be the difference. So we can do that, and let's just do it on a calculator to be safe. So we got 0.9990 minus 0.0582 equals, so 0.9408. So that's going to be your answer. Now, the one thing you're hopefully noticing with all these probability problems for Chapter 6 is that we're using 4 decimal places because of the table. So all of these should have 4 decimal places in your answer. All right. So let's stop there, and then we will start doing an overview of all the different types of problems for the rest of this section. So see you in the next video.